Hi, it's Mr. Duffy. Welcome to physics. Today we're going to be talking about the position time graph and how we can use that. So let's go ahead and get started. Graphs in science really, again, are useful tools that allow us to, again, study lots of information all at once. And that's no different in physics. For this unit, we're studying how objects move. And so a position time graph is going to allow us to study where the object is at a particular time. So, anyways, that's the purpose. A lot of information can come from a position time graph. A position time graph is set up with the position of the object on the y-axis, and on the x-axis is time. Normally, again, we start at 0, so we just set some arbitrary time as 0 when we start our stopwatch, when the object starts moving. Or maybe the object could even already be moving, and again, we just start it at a particular point and measure from that point on. But again, we should think of the position of the object as a function of time when we're looking at this graph. Where is the object at a particular spot at 8 seconds, for example? Now, one thing to keep in mind is that actually a position time graph can have negative positions. We talked about that as far as distance and displacement go, that we normally have, if we're just talking about an object moving along a straight line, if they're moving to the right, we would say that's positive. If they're moving to the left, we would say that's negative. But that allows us then for a position time graph to have those positive and negative values. It can move to the right, it can move to the left, it can move up, it can move down, and we would be able to study those on a graph. But sometimes we don't see those on a graph. If I go back again to the last slide, sometimes we just show the positive values, maybe because the object was just moving in the positive direction. So again, it wouldn't show you the negatives because they're not necessary. But objects that turn around and go back and forth, that might be necessary to show us negative values on a position time graph. So again, it's something that allows us to do that, but not all graphs are going to be set up that way. Okay, so whether again we have those positive values and negative values or whatever, position time graphs can show us a lot of information. So here's where I would ask, what information can a position time graph show us? And let's just start off with some of the basic things that a position time graph can show us. It can show us, obviously, the position of the object at a particular place. Okay. It can tell us, again, if it's, moving in a positive direction or a negative direction. Again, it could be moving to the right, could be moving to the left, but a position time graph can show us that. It can show us, exactly where it is at a particular time. Um, it can show us where the object starts, the x initial, the initial position, and it can show us where the object ends, the final position. With that information, then, it can show us if we figure out where it started and where it ends, we can figure out our change in position, which would be our displacement, like our displacement. The difference between where I started and where I end is called my displacement. Position time graphs can also show us distance covered as well. If the graph is very simple, like this one on the top, the red graph, well, in that case, since it's only moving in one direction, it can tell us right off the bat that it's moved to 8 meters in 8 seconds. So we know the starting position was 0, 0. It only went in one direction. Again, we can figure out the distance very easily. In the blue graph on the bottom, that's a little bit harder because I have a certain amount of distance covered in this first section and maybe something here, something's going on there, and so forth. So that's a little bit, I have to add those distances together. But that is definitely still something that the position time graph can show me. With the blue graph, it's much easier to find the displacement because I can just look at where did it start and where did it end. And then with that information, I can just subtract the two, which for the second one, actually, it ends up being zero displacement because it started and ended at the same place. So that's even easier. So these are some basic things that a position time graph can show you. I say they're basic because really it just you don't have to do much calculation other than just, again, looking at the graph and looking for those values. Distance, you might have to calculate something and change your displacement. You're going to have to calculate something. But again, that's not anything more than just adding or subtracting. Where a position time graph comes in really useful is when we start talking about slope. So one of the things that you guys should be super familiar with doing in your math class is finding slopes of lines. For right now, we are going to focus on position time graphs that have a linear relationship, a straight line. And we should be very familiar with the equation for slope of a straight line. Slope is sometimes referred to as the rise over the run. Or what we should really think about it is the change in your vertical coordinates over the change in your horizontal coordinates. Change in y over your change in x. So what does that mean then for a position time graph? What is our change in our y? What are the units for that? Well, our change in position would be our change in our meters or our distance. Change in distance, or we could say displacement as well, if you want to for now. What are our y or our x units, which are our change in our horizontal coordinates? That's our change in time. What is distance divided by time? Distance divided by time is our speed. We're talking about more specifically change in displacement. If we measure it, from the final position to the initial position, I subtract those two. Change in displacement over change in time is velocity. Okay, so the slope of a position time graph is the speed or the velocity. So that's an awesome tool that we can use throughout physics, is using the graphs to find the slopes of lines. So let's take a look at these two graphs that I had earlier, and let's take a look at those slopes and figure out what they are. The red graph, the red position time graph, fairly simple to find the slope. My change in vertical components, the rise, is 8 meters. And the change in horizontal components is 8 seconds. So the change in vertical, 8 meters, divided by 8 seconds gives me a velocity of 1 meter per second. Fairly simple to figure out, but again, that's a good example of using the slope to find the velocity. In this case, it would also be the speed as well. The velocity, again, it's in the positive direction. So again, a positive 1 meters per second is what that graph is indicating. But again, it's for simplicity's sake also, speed is also 1 meter per second. But again, if we had 1 meter per second in the positive direction, then that becomes a velocity. So now let's take a look at the blue graph. The blue graph is a little bit more complex. It has different portions of the graph at different spots. Let me actually make this one whole page. Okay, now we can analyze this graph a little bit better because it's larger. We can see that there are different segments to this object's motion. Okay, from 0 to 10 seconds, it's moving differently than from 10 to 15 seconds. And then from 15 seconds to 40 seconds, again, it's moving differently. And then the last 40 to 55 seconds, again, a different type of motion. So if we were trying to figure out the velocity of this object over the 55 seconds that it was moving, that would actually be very simple, because velocities are your change in position over your change in time, your displacement over the time. Well, what is the displacement? Delta x over delta t. The displacement is 0. It started at 0 and it ended at 0. So it has 0 displacement, and the time would be 55 seconds. So the average velocity over this entire trip is actually just 0, which really, again, does not paint the full picture of what this object, how it was moving, but it is the average velocity. The average velocity is 0. So Let's look at more specific spots. Let's look at from 0 to 10 seconds. From 0 to 10 seconds, this object moved in the positive 60, had a displacement of positive 60. And it took 10 seconds to do that, like I said before. So, what that would tell me is it has an average velocity of 6 meters per second in the positive direction. Probably, let's just say to the right. Okay. So, again, that gives me, again, a good understanding of what was happening during that first time period. Now, during the second time period, from 10 seconds to 15 seconds, well, during that time portion, it stayed at 60. So the 60 was its initial position and its final position in that spot. So it actually didn't move at all. It had covered zero displacement and it took 5 seconds to do that. So it was moving at 0 meters per second. We would say that object was at rest during that time period. So it wasn't moving at all. Okay, again, this graph gives us, again, a better understanding of what's happening now at these different spots. I'm going to move down as well. Let's go from 15 seconds to 40 seconds. So during that time portion, it went from positive 60 in position to negative 40. So let's write that one out a little bit more. What is that change in displacement? It ended at negative 40, the final position, minus the initial position, which would be 60. It had a displacement of, that'd be negative 100 then. Had a displacement of negative 100. And it took from time of 40 seconds is where it started or ended. And then it started at 15 seconds. So it had total of 25 seconds of motion. Negative 100 divided by 25 is an average speed of negative 4 meters per second. The negative, again, is just indicating the direction. It's telling me that it's moving backwards, maybe let's say to the left, at 4 meters every second. Again, giving a better picture of what's going on during this motion. The last time period, it ends up back where it starts, but it covers 40 meters. It covers 40 meters. I could do that as terms of displacement, 0 minus negative 40, so it'd be 0 plus 40, over the 15 seconds to do that. And then we can calculate what that would be. 40 divided by 15 gives us an average speed of 2.7 meters per second. And that would be positive as well. You can tell it's positive as well because the slope is going up. So again, when I'm going there, really again, the positive and negative really just means direction. So again, each one of those individual portions would tell me a little bit more about the individual motions, even though the average velocity over that whole entire trip was 0 meters per second. Okay. Okay. So let's take a look at some of those individual blocks. Just these are things that you should be able to just recognize when you see that portion in a position time graph. We see a position time graph that has a horizontal line, 0 slopes. That means that the object is at rest. It's not moving. No slope, no motion. If the object has a linear line, that means that it's moving at a constant speed. Its speed is not changing, and that's kind of what we're starting with in this chapter is motion that is not changing. Constant linear line, we can find the slope, the rise of a run very easily. And again, that slope will tell us how the object's moving. It could be positive or negative. A steeper slope indicates a higher speed. Notice both of these lines, the dotted and the solid line, are both moving at constant speeds, but the dotted line has a higher speed because it has a higher slope. The solid line is a lower sloped line, and so again, it has a lower speed. Things to keep in mind, which one of these lines has a higher speed? They're moving in the negative direction. Well, your answer hopefully was the blue line. It has a higher slope. It's more negative, if you can think of it that way. But again, it's covering more distance in less time, but it's just in the negative direction. So again, the steepness, the slope of the line indicates the speed, and higher slopes mean higher speeds, lower slopes mean lower speeds. But again, slopes can be positive or negative. So that is the position time graph and how hopefully this video showed how useful it can be in class in interpreting it. Remember, again, there's a lot of things we can tell just from the graph itself, but finding the slope is really where we get a lot of our information about how fast the object is moving. So hopefully this video is helpful for you, and thank you for watching.